Welcome to this first in a series of videos teaching difficult concepts with Electude. Today we're going to explore teaching voltage drop. So I believe there's two lessons which Electude does a fantastic job of introducing students to voltage drop. Let's take a look at the lesson fault finding. So in this lesson, there's 2 pages of text and there's a series of questions, but essentially students are going to be learning about the V1 through 4 way of measuring circuits. So it's going to begin by measuring terminal voltage, then applied voltage, voltage loss across the ground circuit, voltage loss across the positive circuit. I'm going to put this in presentation mode, and I'm just going to show you some really cool things about the animation. So first of all, Electude utilizes a manual range meter because we feel it's important for students to learn the scales. And then it's going to start out with kind of a simplified view of a circuit, and they have to find the voltage loss. So we're going to begin by checking the terminal voltage, something we always want to start with. So we've got 12 volts. Now we're going to check the applied voltage, or V2. Of course, to have a voltage drop, we have to turn the circuit on. So we've got an applied voltage of 11. So that means we're losing a volt somewhere else in the circuit. We'll go ahead and check the voltage loss across the positive circuit here. So we've got about 100 millivolts dropped across the positive circuit. Now let's check for voltage loss across the ground circuit. And went overload there. So looks like we got about 900 millivolts across the ground circuit. So there is our failure. We have high resistance there in the ground circuit. Let's go on to page 2. Now we have a defroster circuit that the students will use to diagnose and find the voltage loss. So there's a series of, after some preliminary questions here, there's a series of 4 different faults. We're going to go ahead and jump to fault 3 here just as an example. And let's go ahead and, as the lesson teaches, we'll start here with measuring the terminal voltage. So we've got a terminal voltage of 12. Now we'll measure the applied voltage. Of course, we'll need to turn our key on there first. There we go. Turn the defroster on. 0 volts, so we're not getting 0 applied voltage, so evidently this relay isn't turning on. Let's do some more testing here. Let's check to see if we've got available voltage here at the relay. We do have 12 volts coming into the circuit there. Nothing coming out of the relay though, so let's check our voltage applied across the coil of the relay. This would be where to produce the magnetic field that closes the switch. Here we go. So we only got 4.62 volts across the coil in the relay. So we're losing some power here somewhere. Let's check the, I guess we're on 85 here. Let's go ahead and check the voltage loss across the ground circuit. No voltage loss across the ground circuit. Alright, let's move this back over to 86 and check for voltage loss on the positive circuit. 7.38 volts, so we're losing 7.38 volts on the positive side. Let's just check our key here to make sure it's not in the early part of the circuit. 0 volts there. Yep, so no voltage loss through our key. So somewhere between the ignition key and pin 86, we're losing 7.38 volts. So really great lesson that shows kind of a realistic view that still has some numbering there and a schematic along with a manual range meter. And here again, students are going to go through a series of 4 different faults using this V1 through 4 method to troubleshoot these circuits. So a really great way for students to learn utilizing what we call a guided self-discovery approach to learning. Now let's take a look at more of a practical exercise. So this is going to use the engine simulator. So the students get a work order, engine cranks but does not start. Check main relay wiring, it says here. Okay. So we've got kind of a more of a realistic view of the vehicle. So let's just kind of show you some things that we can do here. So of course we got a diagnostic system, got an instrument panel. Let's just confirm here and check our, verify the concern here, and indeed the engine does not start. And we can look at some fault codes here. We got some low voltage codes here. If I clear these, looks like the one that's resetting here right away is the ECM power relay circuit. Okay, so let's put our scan tool away and let's zoom in on this relay circuit over here. So here's our K2 relay. And if we get the old wiring diagram out, we'll take a look at that. So we can make this nice and big on the screen just like that. All right, looks like, let's see here. We should have power out of this relay at terminals 4 and 3. And so we can grab our trusty multimeter here. I guess we should begin, but as the previous lesson has us do, and always start with battery voltage. Obviously, if our battery voltage is much below 12, we're probably not going to power up any of the computers, so that looks good. So no problem there at the battery. So let's go back up to the relay center here. And let's check for power out on that blue wire there. Nothing out there. And the orange wire, nothing out there. Okay. All right, so the relay's not being powered on. Let's go ahead and check for applied voltage across the relay coil. We need this lead back. There we go. And we'll put that across that brown wire there. Okay, we're only got 1.14 volts applied across the solenoid there, which is not enough voltage to make a strong enough magnetic field to close that relay. So we're losing some voltage either on the positive or ground side of the circuit. Let's go ahead. We got the positive on the green and red wire. Let's just move this here down to the positive post, see if we're losing any voltage there. And it doesn't look like it. Looks like we only got about, what, 30 millivolts? 30 millivolts across the positive circuit, so that's well within specifications. Let's go ahead and test our ground. So move that guy over there. And all right, and that's the brown wire. This is our ground, terminal 5. Overload on 200 millivolts. There we go. There's our problem. We're losing almost 11 volts from pin 5 through the ECU to ground. Now we have a breakout box over here. We could go to the ECU and we could hook up this breakout box and check for grounds and all that. But I suspect that the problem is right here in this wire right here. So let's just string a new wire on the car, just like that. So we just replace the wire. You can see the voltage immediately dropped to a lower voltage. And if we move that to millivolts, now we got 30 millivolts drop on the ground side. I bet this car is going to start up. Very good. So there we got a good running car. So this is just a short little example of a couple lessons in Electude that I think do a fantastic job of teaching a difficult concept. You have the lesson on fault finding, which starts with a very simple circuit and progresses to a defroster circuit, but the terminals are still numbered. They still get a schematic view, And then once students have worked with that for a bit, now they experience a simulation that is more of a realistic experience, as they're gonna see on the automobile. And they can do this at home. They can do this at school. You, the teacher, can present these lessons in front of the class. One of the really neat things that I like about using some of these lessons in presentation mode is that you, the teacher, can teach off of these. So even though this is a lesson on fault finding, measuring voltage loss, this is a fully functional meter and circuit in every sense of the way. If I even switch this over to amperage, move this over to amps, I can jumper across this switch, and I guess we'd have to do it from here to here, but same thing. We can jumper across that switch and cause the light bulb to come on. So we got 1.83 amps flowing through that circuit, and that's a pretty cool thing. Somebody had to program that in there, thinking that, a teacher might use this in the classroom to teach other concepts. And so here we have a lesson that's on voltage loss, but the ammeter works. I just think that's a very unique thing. What really drew me to Electude, and I think that as a teacher, you're going to enjoy using these animations to teach off of, to teach voltage drop, to teach voltage loss. Can be somewhat of a difficult topic to teach. There I blew a fuse, of course, because I had it in the amp meter socket. Very difficult concept to teach, but a lot of fun. This can really change the whole dynamic of your classroom, to be able to use some great animations like this to teach off of, whether you're in presentation mode or you're inside a lesson. Electude does it in a very unique and fun way. So that's kind of my quick little demo on how we teach voltage loss or voltage drop. So thank you and have a great day.